Commissioned by JKR, the smart traffic light system ensures the pedestrian safety by integrating synchronized traffic signal with an LCD display. The system operates by detecting a push start activity, triggering the traffic light to turn red for 30 seconds while the pedestrian signal turns green, ensuring the safe crossing. The LCD provides clear and real-time instructions such as walk to guide the pedestrian efficiently. This diagram represents a traffic light control system using the Dragon Board 12 Plus microcontroller. It receives input from port H0 and a switch button, switch 5, to control a traffic light which is port B0 is red, port B1 is yellow, port B2 is green, and a pedestrian traffic light which is port B4 is red, port B5 is green. Additionally, an LCD display is used to show a walk signal for pedestrians when it is safe to cross. The diagram outlines the wiring and the pin connection for a traffic light system on the Dragon Board 12 Plus, including the resistor, switches, and the swap, possibly transistor for LED driving. Switch SW5 triggers the pedestrian crossing, while deep switch SW1 set the predefined traffic light modes. The system operates in a cycle, transitioning from red to green, yellow and back to red for smooth traffic flow. Programming the Dragon Board 12 Plus using a microcontroller script and testing the setup with LEDs are the next step. The LED-based traffic and pedestrian light system design include main traffic light, which is port B0, port B1 and port B2, and the pedestrian signal, which is port B4 and port B5, with additional LEDs, which is port B3, port B6 and port B7 is for auxiliary functions. A ground connection is provided via port J1 and 2.7 kilo ohm resistor are used to ensure the proper LED operation by preventing the overcurrent. We use the LCD to provide the real-time status update, ensuring the pedestrian and the driver receive the clear visual and feedback on traffic light changes. When a pedestrian presses the activation button, the microcontroller will synchronize the traffic light and the LCD message. This flowchart represents a pedestrian crossing traffic light system. Here is how it works. The start shape represents the system begins its operation. Next, the traffic light turns green, pedestrian light turns red, meaning initially the traffic light for vehicle is green and pedestrian crossing light is red, meaning pedestrian must wait first. And next is continuing press push button, meaning the pedestrian must presses the button PH0 to request to cross. Next, the system introduces a short delay for 50 milliseconds for button to process. For next 5 seconds, traffic light turn yellow, meaning the traffic light changes from green to yellow and stay yellow for 5 seconds. Warning vehicle to slow down for next 30 seconds. The traffic light turn red, mean vehicle must stop, and the pedestrian light turns green so that pedestrians are allowed to cross, while LCD display walks in big uppercase letter as a visual indicator to tell pedestrians it is safe to cross. Lastly, the shape N means the process end and the system likely reset to initial state.
This is the coding for the pedestrian traffic light mini project. So first we include the ACS12.inc and define the LCD pins. Then we initialize the step pointer and LCD. So next is configuring the input and output ports. So we configure port B as output and also J1 as output and ground. So and then we configure the port H0 as input for our push button. Moving on to the main traffic light sequence, the coding before pressing push button is included. So before pressing on the button, port B is when the traffic light for the road is green and the path for the pedestrian is red. After next, the code when pressing the push button is also included as well as after it's been pressed. The traffic light will show yellow for the road and still red for the pedestrian for 5 seconds. After the 5-second delay is where the pedestrian can cross. So LED on port PB0 will turn red and LED on port PB5 will turn green. So when it happens, based on the coding, we put a 30-second delay before it changes back to green for traffic light and red for pedestrian. So we also included the LCD to display walk during the 30-second delay based on the coding. So after the delay, the LCD will also clear up based on the coding we put. So this code clears the LCD every 30 seconds and implements a delay subrouting, which is the delay 5S, that creates a 5-second delay using nested loops. So where the delay 1 produces a 5 millisecond delay, so delay 5S repeats it 250 times for 1.25 seconds. So and delay 5S runs multiple times to reach the required delay before allowing the program to continue. The coding after 30-second delay continues by implementing two delay subroutines, which is first is D30 second for a 30-second delay using nested loops, and D15 millisecond for a 15 milliseconds delay, while also defining an LCD message walk to be displayed. So the message to display on LCD, we included a delay 1.asm for delay routines and also include LCD Dragon 12.asm for LCD routines.
This is our result for the question that is simply described on the project description without LCD, which is the innovation that is done on our part. This is our result for the question that is simply described on the project description without LCD, which is the innovation that is done on our part. This is our result for the question that is simply described on the project description without LCD, which is the innovation that is done on our part. This is our result for the question that is simply described on the project description without LCD, which is the innovation that is done on our part. This is our result after innovation is done, that is using LCD to display walk to improve safety for pedestrian, accessibility for visually impaired individual, and it is energy efficient and cost effective. This is our result after innovation is done, that is using LCD to display walk to improve safety for pedestrian, accessibility for visually impaired individual, and it is energy efficient and cost effective. This is our result after innovation is done, that is using LCD to display walk to improve safety for pedestrian.
The smart pedestrian traffic light system improves safety and efficiency by synchronizing two-way traffic signal and offering an on-demand crossing feature. It turns red for 30 seconds upon the button activation, providing a real-time instruction and minimizing traffic disruptions. Challenges like timing synchronization and display updates were addressed through iterative testing.
This is the advantages of LCD integration. First, it will improve safety for pedestrian. The LCD display reduces confusion, especially for individuals that is unfamiliar with traffic light, such as children and elderly people. It serves as an additional safety layer, reinforcing meaning of pedestrian light. Second is its accessibility for visually impaired individuals, such as those with color blindness. They may struggle to differentiate between red and green LED light, so an LCD display with text instruction overcomes this issue. Thirdly, it is energy efficient and cost effective, as LCD consume less power compared to lighted signboard. They are also versatile, as allowing for easy modification to display without changing the physical setup.
In conclusion, during testing, the system performed efficiently with traffic light transitioning smoothly and pedestrian signal activating as intended. The LCD provided a clear instruction ensuring both safety and optimal traffic flow. The innovative design successfully combined the functionality, efficiency, and user-friendliness, achieving the project's objective with minimal vehicle delays and seamless operation.